Diving into Chapter 2 here in Contemporary Math, starting with some percents, some sales tax, and a little bit more. To start off, let's start with some basic percents. Like on number 1, if you want to find a percent, they say 243 people out of 400 state that they like dogs. What percent is that? Well, we just kind of do a little fraction, 243 divided by 400, and then we punch that in. 243 divided by 400, and they're going to give us a decimal back. So do you realize to change that to a percent, we're going to move the decimal 2 places to the right. So if this says 0.6075, we're going to make it 60.75%. Are we cool with moving the decimal 2 places to the right to change it to a percent? If it comes out really nasty, we're going to round it how they tell us to round it on the homework program. Maybe they say to the nearest 1/10 of a percent. Maybe they say, like, round it to 2 decimal places in that situation. Okay, so on number 2, 234 racers who started a marathon. Out of all those, so this is like our total number right here, right? They say, hey, these are all the people that were in a marathon. 199 finished that race. Cool. But a marathon's a long race, so 32 people gave up, and 3 people were disqualified. Don't know why. Maybe they took a shortcut, maybe they did something bad, whatever, but they were disqualified. What percentage did not complete the marathon? So how do you feel about these guys are the ones that didn't finish? They either gave up or they got DQ'd. How many total people is that? 32 and 3? 35 people did not finish out of the 234. Why don't you punch that in, and let's get a decimal for that, and then we'll move it 2 places. So I punched that guy in, and there's a nasty little dude right here. Sometimes they even say round to the nearest percent, right? To me, that would be this question. And like I said, just got to read for detail on homework how they want you to round. So it'd be like 14.9, actually 15.0. How do you feel if we call that about 15% of the people did not finish the race in that case? Does that sound all right with you there? Basic percents. Then the other thing is, like, when they pay sales tax, you all have been around long enough on this world that if you buy something, there is sales tax in that situation. If you're currently in Hayes America, it's 9.25%. But they give us a bunch of random ones based on what areas you live in, right? You know, so a sales tax in the town is 9.4%. How much tax will you pay on a $140 purchase? The secret to success is we got to change this number to a decimal. And instead of moving the decimal 2 places to the right, don't we need to move it 2 places to the left? So wouldn't that be 0.094? Are you with me on that? And I'll take that times 140. I don't care that you show that work. If you can do it all in your calculator, it's fine with me. Does that make sense? You know, like, I'm not grading work on this. I care that we can get the right answer. So 0.094 times 140. And that came out real nice for money. I hope that we know at this age that money is 2 decimal places, right? You know, that came out real nice. If it doesn't come out nice, we'll always round money to 2 decimal places unless they tell us different. So $13.16. The dollar sign goes in front of the numbers, guys. It's kind of like a little pet peeve that I have with humans in this world. The dollar sign doesn't come last. It comes first, right? So let's see if we can do that here. Of the amount of tax, find the amount of tax and the selling price. So whatever the item is you're buying, the sticker says $32.99. You got to pay tax on it, though. So let's find the tax amount. Let's take 0.0925. Sorry, I hit the wrong button. Let's take 0.0925. 0.0925 times $32.99. This is where we got to think about, like, if we're the government. The government is the people collecting the tax. Math rules say that should be 3.05 if you round it, but guess what the government's going to do? Do you think they're going to round up or round down every time? They're going to round up, right? So we're going to make that $3.06. Are you with me on that? Like, we're going to round it up, even though the math rules say that. So 306. So that's the tax that you pay. How do you find the total? Don't you add up the $32.99 plus the 306, right? So if you want, in your calculator, you could just hit plus $32.99 and then realize it's still rounded up that penny, or you could just hit $32.99 plus the 306. And either which way, shouldn't it be 36.05 in that case? Did you get 36.05? Yes, no, maybe? Cool. So that, pretty basic stuff. It gets a little more challenging. You see in gray, I have given you some hints. This is why you're going to want to keep your practice worksheets, because these formulas, you're going to be like, okay, by the end of the day, whoa, you know. So if they give you a sale and then they mark it down again, there is a secret. So let's just read the first one. A store has clearance items that have been marked down by 15%. I want to stop right there. Nobody cares how much it got marked down. Don't you actually care how much you pay? Like for you as the buyer, don't you care how much you pay? So if they took off 15%, what percent are you paying? 85%. Does that make sense? If they take away, so this to me means we need to use 0.85. That's what the secret to this formula is how much you paid. They took away 15%, you're going to pay 85%. But then here's what they did again. They said, oh crap, this stuff still isn't selling, so they're going to mark that off. This already been marked down. They're going to mark that off another 30%. They're going to double discount it, right? But again, I don't care how much they took off. I care how much they paid. So clear your mind. If they took off 30%, how much are we going to pay? 70%. Are you with me on that? 30%, it all adds up to 100%. So they're going to take off 30%. So we're going to pay 70%. Those are the two decimals that you need to multiply together, is how much you paid. So grab ye old calculator, and let's punch that in. 0.85 times 0.7 or 70, however you want to type it in. And do you see how we got that? So that's 59.5%. You got to move the decimal 2 places again to the right. So if they took off 15% and they took off another 30%, you ended up paying basically almost 60%. It's just kind of a weird thing that you got discounted twice. The secret to this success, you might want to circle that in the notes right there, is use the number that you paid. And see if that makes a little more sense when I pick some really round numbers. Hey, if they take off 50%, how much are you paying? 50%, so still got to figure that out. And then, hey, they had another sale, so there's 50% off. They're going to take an additional 50% off on that, so we'll pay another 50%. And if you multiply those together, see what happens. 0.50 times 0.50. How much did we end up paying? 0.25, which is 25%. I picked those numbers to see if that makes sense to you. Half off. Cool? And then we're going to take another half off of that. Would you believe you're paying 25%? Because you took it in half, and then you took it in half again, you know, and that's 25%. So if you have questions on those, I titled, you know, like what's going on. It's like, hey, sale items, mark down again. Look back to your notes, see what we did for a little formula there, and we'll do that. Here, grade calculations. You get some questions on homework about somebody's grade, right, how they calculate it. So I got a little formula here for you. It makes a lot more sense if we dive in and use it, and then we can look back to the formula. So Yolanda has an 85% average before the final exam. That's her current grade in the course. Right now she's got 85. Cool? The score includes everything but the final, which counts for 25% of her grade. What is the best course grade Yolanda can earn? So we got to do a little thinking and a little calculating. So here's what we're going to do. Her grade is going to equal this. Do you know her current percent in the class? What is it? 85. We'll change that to a decimal. You'll probably want to write some of this down too. This is one you're not the most successful with just doing it in a calculator. We're going to write a little bit down, okay? But then you have to count it for how much it's weighted in the course. Do you see that the final counts for 25% of her grade? So guess what all the other stuff counts for? If the final counts 25%, how much should the other stuff count for? 75%. So we're going to take that times 0.75. This is her grade for like all her homework and all her other stuff. It counts 75% of her grade. Then the formula's got a plus. Here's where we're going to like sneak it a little bit. Before I put in that blank, Do you realize this is her final, and it counts for 25% of her grade, so I'm going to put that 0.25 in there. But since the question asked, what's the best course grade she can get, you tell me, what's the best score you could get on a final? 100%. Would you agree with that? Like, you've got to get 100 on the final, right? Which is a hard number for people to put in here because we got to change it to a decimal, right? You can't put 100 in there. You have to take 100 and move the decimal 2 places to the left. Isn't that the number 1 in that case? Like 100% is literally the number 1. Why did I put that in there? Because they asked me, bro, what's the best she could do in the class? Okay, that means she's got to ace the final. That's the best score you could possibly get. Cool? And now I'm going to punch this in my calculator. So you can just punch from left to right. I kind of use parentheses. It's not that you have to, but, oh, sorry, I hit the wrong button. Maybe if I hit the right buttons, 0.85 times 0.75 plus, got to move out of the way of my recorder there, 1 times 0.25. You can type that if you want. Are you cool that 1 times 0.25 is just 0.25 also? So 0.25. And there you go. That's the best score she could get in the class. So 0.8875. Read the homework to see how they want you to round it. We should probably round that to a percent. So I don't think that we'll call it 88.75%. What would your teacher do? Give you 88 or 89? You're going 89 on that. You're going to round up, right? So the best she could do is an 89%. So that's a great question that students ask. Like, can I get an A in the class? What do you think? Can she get an A in the class? The best she can get is an 89. Can she get an A in the class? No, not quite, you know, in that situation. Then a lot of students ask this. It's like, what's like the worst I can do on the final to still get a B? You know what I mean? Like, what's the worst I can do? So let's kind of set it up like this. It says, what is the minimum score she needs to get an 80% in the course? Make some notes for yourself if you need it. This is the final grade. This is the grade. This is what she wants. That goes in right here. They're telling you, you want to get an 80, so that's got to go in right here. So I'm going to start with 0.80. If you want to call it 0.8, I get that, but I'm just writing it as 80, right? Then these numbers didn't really change. She still has an 85 in the class, and it counts for 75% of her grade, so those numbers didn't change. But what we don't know is her final exam score, so we're going to let X be that. And yeah, we got a little bit of algebra to do. We're going to let X be that, but doesn't it count for 0.25 or 25% of her grade? Let's clear this up for our brains. Does anybody know what X times 0.25 would actually turn out to be? So I'm going to write that as 0.25X instead. I think my brain's going to like that better. What I'd also like to do is punch that blue nugget in my calculator and just get 1 decimal out of that. So let's do 0.85 times 0.75. And you see that's 0.6375. So I'm going to bring all that other stuff down. 0.6375 is what that turned out to be. And the decimals are just kind of not the prettiest looking thing in the world, but this is your very, very basics of an algebra equation. I'm trying to get this all by itself on one side of the equal sign. Can't I move this over to the other side by subtracting it over? Right? So I will do that. 0.80 minus 0.6375. And I got that little decimal, 0.1625 equals 0.25x. What's my move now to get x all by itself? There is a times 0.25 hanging out with it. How can I get rid of that? We're going to divide both sides by 0.25. So divided by 0.25. And that's what we got. X, sorry if it was 0.65 is what it showed up to be. So what is the minimum score she needs to get an 80% in the course? It's not actually 0.65. We've got to change it back. What's it got to be? 65%, which seems pretty decent. You know, it's like she's got an 85 going on, you know, she wants to get an 80, so she's got some leeway room, you know. It's like she can do not the hottest on the test, and it'll be all right. But let's do another one of those, right? You know, I think we could practice another one of those, right? So if you flip to the back side, here's Rita. Let's do the same thing over again. Rita's got a 72% in this class, right? So the score includes everything but the final, but this time it only counts for 20% of her grade. What is the best she could do? It's going to be just like Part A from above right here. We're going to use our formula. Her grade is going to be the percent she currently has, which is 0.72. And here's where you got to do a little calculations. If the final counts for 20% of her grade, what does everything else count for? What is it weighted? That's what that's called. That's the weight of it. What is it weighted? Not 20%, but 80. 80% is what that will be. 20% was her final. 80% is the other in that situation. The best she could do, right? The best she could do. What is the best grade she could get on a final? 100. How do we put that in as a percent? 1. And then we'll take that times 0.20. Go ahead and punch all that in your calculator, and let's see what she can get. So I got her all punched in. I like to I guess I'm not really grading work, you know, so what would that be, 77% or 78%? What would you do on that? 78%. Cool. What is the minimum score she needs to get? A 60? I do like to put a little bit of brain power to this. She's currently got a 72, right, you know, which is not as good as the other girl before, right? She's currently got a 72. She wants to get a 60. It seems achievable, you know what I mean? It seems achievable. Would you do me a favor? Could you try to set up the numbers and then check it out with mine, see if we get the same thing? Use this formula. You can look up to mine if you want to see how we set it up, or you can flip back and forth. Set it up, see if her grade, 60%, should equal the percent that she currently has times the weight. It's the same as over here as before, plus I don't know what she's going to get on the final, so times 20% in that case. What I'm going to do then is clean things up. I'm going to figure out what's in this box. What's 0.72 times 0.80, 0.567. Change colors. And then this is 0.20x in that case. My move then is to subtract this guy over to the other side. Right? I shall subtract this guy over to the other side. So 0.60, take away that. Did you get 0.024 when you did that? And then finally, I will get rid of the times 0.20 by dividing. So 0.024 divided by 0.20 is this. What is the minimum she needs to get on this final exam to get a D in the class? What does that mean? Go ahead. Made a mistake. Sorry about that out there in video land. I just kind of looked at the wrong question on this. This should be 0.033. Is that the number that we're getting covered with? So sorry about that if you're watching the video. And now we shall divide by 0.20. Thank you for fixing me. How about 0.165? So what percent does she need to get on that final? We'll round to the nearest percent by moving that 2 decimals. What do you want to do, 16% or 17%? We'll do 17%. 17%. Man, if you need help with that, come see me. I will help you with that situation. But here is the formula. When they ask for grade calculations, we're going to get out this practice sheet. We're going to look at it. Yes, you can use these sheets on your quizzes that we have, right? That's why I gave them to you. So, all right, finding a value before a percent decrease. Are you guys cool with the fact that when I type OG, that means like the original, like calling it the OG in that case? So here's what we got. An article reports that attendance dropped 4% this year to 8225. What was the attendance before the drop? So this is the new value if you want to like make notes for yourself. This is the new value. We don't know the original value. That's what they're asking us to find. It's like, yo, bro, what's the original value? So right here, I say, why don't you let x equal OG? Instead of me putting x's in this formula, which confuses a lot of students sometimes, I literally put OG in there so you kind of know what it is. And then it's like, all right, we're going to put an X in that spot. So here's what we're going to do. We're just going to write from left to right. Do you know the new value? Yes or no? That is this number right here. So we'll start with it. There is an equal sign after that. The next thing is the OG, the original price, or not price, excuse me, but the original attendance. I don't know it, so we're calling it X. We're putting X in for that. Then there is a minus. Then I got to do the OG again times the percent lost. Are you down with the fact that they lost 4% of the people in this case? So I'm going to write that as 0.04 times X. Because I switched them around. Yes, you're right, I should have the X first and the 0.04 second, but I'm a math dude, so I know numbers should come before letters kind of stuff. So that's all that. And this kind of confuses some people. Right here, are you down with the fact that there's literally one X right here? There is a 1, and here's 0.04. These are like terms. So what I can do is combine them together. Mr. 8225 is going to come down, and 1X, take away 0.04X, is 0.96X. And what I want to do is see if you like this formula better than the orange box formula. Here is a blue box formula. Could you see where this came from right here? They lost 4%, or it decreased by 4%. How much did they keep? If you lose 4%, how much do you keep? 96%. Are you with me on that? Either one of these formulas works. The blue one is a shortcut to where the orange one would get you. So if you're like, okay, the new value equals the percent kept, right? They lost 4%. I want to know how much they kept, right? So they kept 96%. What's my move to figure this out? Isn't this a times 0.96 in that spot right there? Let's divide both sides by 0.96. So 8225 divided by 0.96. And shouldn't that number go up, right? Because they decreased, so it went up, right? The instructions say round to the nearest person, so let's do 8568. Does that sound okay to round that to the nearest person in that case? So X is about 8568. And it'll have like a label on it on the homework already, but it is in people in that case. So let's see, with only one of those examples, could you set up this situation for you? Figure out who your new is and like what you would do. You can work together on it and see what you think. Pause the video, give it a shot, check with mine. So that's what I got. Here's my new price. It equaled, I kept 83% because we took away 17%. So if you punch that in, all right, $6.99 divided by 0.83, baby. They tell us to round to the nearest dollar, right? Round to the nearest dollar. So let's do, the homework program is probably going to be okay with either 842 or 843. Sometimes they give you like a little bit of leeway on that, right? But if it doesn't give you the 843, then type in 842 and see if that gives it to you. Math-wise, it should be $842. So $842 bills, y'all. Are you cool with finding a value before a percent decrease? Your job is, when you find questions like that on homework, look for this situation and use the gray box to help you with it. All right. Finding the original price after tax. So a man realizes that he lost his receipt from the store and can only see the after-tax total on his credit cards app. Here's our shortcut formula right here. Here's the long way formula in orange. I'll do both. Do we know the final price? Sorry, I thought that was a highlighter. Do we know the final price? Yes, we do. Isn't that the final price right there? So we're going to start with that. $595.10. That's the after-tax total. That's what you paid after tax. That's your final, dude. This is your payment. That equals the original price. One more time. I gave you a little shortcut. Call him X, because that's what you don't know. You don't know the original price, so that's going to be X plus your tax times the original price. Got to change it to a decimal. And this is where that shortcut formula comes in. It's really 1.082X over here. If you just like add 1 to your tax rate, that's what that turns out to be. So we got all that. Don't we just divide by 1.082 to get that done? Clear all this out. 595.10 divided by 1.082. How much was that bad boy? $550. That came out super clean. Don't expect it to every time. It might not come out to be perfectly clean, you know, so if it was something that didn't round how they tell us to round. But whatever he bought, you know, let's just call it a TV or something. He bought a TV. The sticker said $550, but he actually paid $595.10 because he had to pay the tax on it. So we knew that. Could you try setting up number 12 for me? Pause the video, see what you think. I used the shortcut formula. This is my final price right here. Boom. And I did 1 plus my tax, 1.09% times the original price, which we're calling that X. I don't know the original price, so that's why we use X there. And then if we just divide, 35,300, was that the right number? I think so, yeah. Divided by 1.09. There is where it didn't come out very nice, so it says round to the nearest something, nearest dollar, so I'll do 85 bucks. I'll bet the homework program would be happy to put 86 bucks in there also. $32,385 is what that turned out to be. Yummy. All right, last thing, man, cigarette time. Please have a mature attitude about the problems that we have about like cigarettes, vaping, and drinking and stuff like that. I know you can do it. But a state government is considered to change this thing called an excise tax. What's an excise tax? It's a tax that's just automatically built into something. It happens on our gasoline. You know, it's like when you pay gasoline, it's got the price of gas plus tax built in already. Right? It's like you don't, like if you put 50 bucks in the pump, you don't have to pay tax on that, right? You pay 50 bucks because the tax is built in. That's called an excise tax. So the government said, hey man, maybe we should change this. The excise tax currently is 40 cents per pack. So if you wanted to buy a pack of cigarettes, they have built in 40 cents already as tax on that situation. You with me on that? So you see right here, they gave us the price of the pack is $4.95. It's got the tax built in. Let's go off to the side and figure out what the actual cigarettes themselves cost, right? So if 40 cents of that was tax, how much is the actual cigarettes, dude? $4.55 for the pack, you know, by itself. Without the tax, the cigarettes themselves literally only cost $4.55. Why is it $4.95? Because they put 40 cents on it for built-in tax called excise tax. But here's what they're asking. It says, what would the sales tax rate need to be to make them the same as the excise tax, right? So here's what we'll do. We'll do this. We'll say 0.40. Isn't that literally what the excise tax is? It's like, okay, I want 40 cents to be this. The unknown thing times 455. It's like, what would I have to take 455 times? Where'd 455 come from? That's the price of the cigarettes, right? I want to know what I need to multiply that by to get 40 cents back. How do I solve for x? This is x times 455. How do I get rid of that times 455? Divide. So sorry, I hit the wrong button. 0.40 divided by 4.55. And I got that. Ugly decimal. It should be an ugly decimal because they're asking what the sales tax should be. So I'm going to call that, how about 87.9? Like 8. Let me look at that again. Let me see what so if I move the decimal 2 places, about 8.8%. How does that look in that case? You cool with me moving the decimal 2 places to the right, and then I got to round that 7 up because of the 9 after it? Are we okay with that? You can shake your head no if you're not okay with it. Are you okay with what I did? So the sales tax, for it to be the same, is 8.8% in that situation. Wow.